Jupiter's Great Red Spot has been shrinking for over a century, and scientists still cannot agree on why. For most of human history, this storm was the largest visible feature in our entire solar system. A swirling crimson hurricane so vast that two Earths could fit inside it side by side. Astronomers in the late 1800s measured it at roughly 25,500 miles across its long axis. That is longer than 3 Earths placed end to end. It seemed permanent, geological, almost eternal. And then, slowly, it started to disappear. When the Voyager 1 and 2 spacecraft flew past Jupiter in 1979, they measured the Great Red Spot at 14,500 miles across, already significantly smaller than a century before. Hubble picked it up again in 1995 at 13,020 miles, then 11,130 miles in 2009. By November 2023, amateur astronomer Damien Peach captured images precise enough to measure it at just 7,770 miles, and as of January 2024, Hubble clocked it at 8,700 miles across, the smallest measurement ever recorded. In roughly 150 years, the storm has lost more than 2/3 of its original size. That is not a gradual fluctuation, that is a collapse in slow motion. Here is where the story gets genuinely strange. Most coverage of this topic frames the Great Red Spot as simply shrinking, as if it is fading like an old photograph. But when you look at the actual measurement data, two things stand out that rarely get discussed together. First, the shrinkage is not uniform. A 2018 scientific study tracked the storm's dimensions precisely and found it is losing size much faster along its long axis than its short one. The longitudinal shrinkage rate is 0.01994 degrees per year. The latitudinal rate is only 0.0048 degrees per year. In plain terms, the storm is not shrinking evenly, it is being squeezed. Its classic oval shape is collapsing toward a circle. Since 2012, that process accelerated. The spot started losing roughly 580 miles per year. Before that, the shrinkage was slower and steadier. Something changed around 2012. Nobody knows exactly what. Second, and even stranger, the storm is not sitting still while it shrinks. Hubble observations taken between December 2023 and March 2024 revealed that the Great Red Spot oscillates. It wobbles. Scientists described the motion as similar to gelatin jiggling on a plate. The entire storm pulses and shifts as it spins. This is not what you would expect from a structure simply losing energy and winding down. It behaves more like something that is still actively responding to forces we have not fully mapped. To understand why this matters, you need to know what the Great Red Spot actually is beneath the clouds. In July 2017, the Juno spacecraft made its first close pass directly over the storm. What it found rewrote the basic picture. The roots of the Great Red Spot do not sit at cloud level. They penetrate approximately 200 to 300 kilometers below the cloud tops. That is deeper than scientists expected for what is, at its surface, a weather system. Juno also found that the storm's base is warmer than its top. That temperature difference, warm below and cold above, is what drives the ferocious winds visible at the surface. The Great Red Spot is not just a storm. It is a coherent three-dimensional structure anchored deep in Jupiter's atmosphere, with its own internal heat engine. So what is causing something that deep and that powerful to shrink? Several hypotheses exist, none are confirmed. The leading one, published in 2024 by researcher Caleb Keaveney and colleagues at Yale, argues that the Great Red Spot is not self-sustaining. It depends on a steady diet of smaller storms. In this model, the spot survives by absorbing nearby eddies, those smaller rotating systems that drift through Jupiter's atmosphere. When smaller storms merge into the Great Red Spot, they feed it energy and reinforce its structure. When that supply of smaller storms runs low, the spot has nothing to absorb, and it begins to contract. Keaveney's team ran three-dimensional computer simulations to test this. In simulations where smaller storm mergers happened regularly, the Great Red Spot maintained its size. In control simulations without those mergers, the storm shrank noticeably over roughly 2.6 Earth years. The math matched the direction of what Hubble has been observing. But this hypothesis has not been confirmed by direct observation. We cannot yet track the full population of smaller Jovian eddies well enough to know whether the current rate of mergers has actually declined. It is a compelling model. It is not yet proven. There is another layer to this story that upends a common assumption. Many people, and even some early scientific discussions, treated the Great Red Spot as the same storm that astronomer Giovanni Cassini observed between 1665 and 1713. That storm, called the Permanent Spot, was visible for about 48 years and then disappeared entirely. The implication was that the modern Great Red Spot was a storm that had somehow persisted for over 350 years. A 2024 study led by Agustin Sanchez La Vega and colleagues directly tested that assumption. Their conclusion: the modern Great Red Spot is almost certainly not the same storm as Cassini's Permanent Spot. The two were likely separate phenomena, which means the Great Red Spot we are watching shrink today is probably younger than we thought. Still old by any human standard, but not a 350-year relic. This matters because it changes how we think about what the storm could do next. If it is a younger system, we have less historical data to anchor our predictions. What happens if it keeps shrinking? NASA scientist Amy Simon has offered one of the more grounded assessments. She suggests the Great Red Spot will not disappear entirely. Instead, once the storm shrinks to a size that fits within its natural latitude band on Jupiter, the atmospheric winds surrounding it will essentially hold it in place. The storm stabilizes. It stops shrinking because the geometry of Jupiter's own wind structure prevents it from collapsing further. In that scenario, the Great Red Spot does not vanish. It becomes a smaller, rounder, possibly less intensely colored version of itself, a shadow of what it was. Whether that counts as survival or as a different kind of ending depends on how you define the storm. The honest scientific answer right now is, we are watching something unprecedented happen to the most famous storm in the solar system in real time, and our best explanations are still hypotheses being stress-tested against new data. The Juno mission continues to orbit Jupiter. Hubble keeps imaging, and every year the measurements come back a little smaller. Whatever the Great Red Spot becomes, it is changing. The question that remains is whether we will understand why before the transformation is complete. If you enjoyed this video, consider subscribing to the channel.